Last one. All right, a logistic function. These are used for population. All right, they look like this. This function is very large, okay? And it looks like this. F of x equals 1 over 1 plus e to the negative x. Okay? The way this function works is that the graph starts off down here, comes up, and it goes through this function, and then it levels off. Okay? It levels off at 1. Okay? So what happens is something starts off really small, it grows pretty fast, and then it levels off. The reason that this is a population function is because this is how populations grow. For example, if I put a bunch of small fish or minnows in a pond, they would reproduce and you'd get a lot of fish. But what would happen after a while? They would die. Why?
Because they get old. They eat each other.
Okay, but then they would produce more. But why would you max out on a population?
Vows of celibacy. Too much room.
That's right. There's only so much room in the pond. That's correct. And so all populations max out. Okay? Mostly you see this in nature that populations max out. All right. What is my domain? What x values work?
Human population hasn't maxed out.
No, it has not yet. You are correct. What is the domain?
Negative infinity.
All right, negative infinity to infinity. And what is my range? 0. Does it equal 0?
No.
No, it is and it goes up to 1. Okay, these two things right here, it has 2 horizontal asymptotes. All right. Okay, now, keep these. Do you guys have all these pictures in your notes? Okay, you need to refer to them. Okay, here we go. Domain. How many functions have negative infinity to infinity domain? How many? No, count them. Count. How many?
Negative infinity.
Yep. How many have it from negative infinity to infinity?
3. There's 4, 5.
How many?
6, 7, 8.
8 of them do. So 8 have this sort of a domain where it's unrestricted. Okay? And that's what you're going to be asked to do. What about continuity? Do you remember what continuity was that we talked about? That's right. How many are continuous? Gabe?
What's up?
Right there. How many are continuous, have full continuity? With no breaks or jumps or skips? Look at your...
The functions?
Yeah. 9 of the 12?
I'm pretty sure, like my colleague stated, there's 9.
Are you sure?
I'm positive.
Okay.
I say 10.
I'd say there's more than that, but okay. Let's go with 10.
All 12.
Sorry, Mrs. Pat.
No, I don't think there's all 12.
The greatest integer one is not.
Yep, the integer one is not, and the reciprocal. The square root function, that's an interesting one because it is continuous, what we say, on its domain. So even though it's not negative infinity to infinity, where it's drawn, it is continuous. Okay? All right, boundness. Remember we talked about boundness. Okay? Which ones have lower bound?
Absolute value.
Yep, absolute value. Squaring. I think that's about it. Are there any that are straight up bounded? Top and bounded, bottom.
Yeah.
Sine and cosine.
Definitely sine, cosine, and one more.
It was like the last one we just did.
What's the last one we just did?
Oh, it's called logistic.
Yes, logistic. That's right, because it has those asymptotes on the top and the bottom. Okay? And the last one we want to talk about is symmetry. How many of them, okay, Gabe, I'd like you to kind of pay attention, please. How many of them have even symmetry? Carter, if you could look also. Count on your graphs. Remember, what is even symmetry? You can fold it over the y-axis. How many?
3.
Isn't it the same on the other side?
Yep. And so what are the three? Was what? X squared,
Cosine.
x squared, absolute value.
Yeah.
That's it?
Shouldn't there be?
And cosine.
Yeah, cosine.
Okay? How many of them have odd symmetry? What was odd symmetry? Do you remember? Odd symmetry was that if you take the graph
Oh, so it comes
and you flip it upside down or turn it 180 degrees, it looks the same. So which ones look the same upside down and right side up? Any, which one? Which one, Casey? Okay.
3.
Think 3 of them? What are they?
4.
4? All right, what are they? Name them.
There's sine.
Sine is a for sure one. The identity function, which is just x.
Logistic.
No, not logistic because it's off center. It won't look the same. Which ones? Cubic, good. And one more. One more, guys. Reciprocal, 1 over x. Okay? All right, that one has symmetry. All right? Nope, it has. Now, if it's not one of these, because there are 12 functions, and this only takes care of 7, that means that 5 of them have, it's neither, we just talked about 12 of them. Okay? All right, now, the last thing I want to talk about today is piecewise functions. Have you ever seen them? All right. A piecewise function is a function that has obviously a couple of pieces. For example, f of x equals x squared. You draw the x squared graph if x is less than or equal to 0. And you draw the square root function if x is greater than 0. Okay? So this is what it looks like. Okay, when x is less than 0, I have to draw the x squared function. All right, and what does that look like? Like this, right? Okay, and you put a solid dot there because it equals 0 there. Now, if x is bigger than 0, okay, if x is larger than 0, I draw the square root function, and that looks like this. Okay? So a piecewise function has different parts to it. This tells you where to draw the parts on the domain. Okay? All right. Any questions?